Again, welcome to Calculus. In these lectures, we're going to discuss about mathematical modeling in business and economics. This is our unit 1, lecture number 8. Again, we are still in the pre-calculus subjects. After these lectures, again, we will move on to limits, which is the beginning of calculus course. So our main objective here is to recognize and also understand various business and economic terms. Also, we are going to learn how to create and evaluate mathematical models for real-life situations. So most of the examples in this lecture is about real-life problems. So our first problem is, how do we calculate simple interest when we invested money or a finance in a banking institution? So how the banking institution calculates a simple interest. So normally, to calculate a simple interest, we multiply the principal amount that we are investing. As the amount we are investing is the P, the principal. Then we multiply it by the rate of interest, the annual interest rate the bank is giving us, times the period of time. Normally, the time will be in years. So, for example, in the bank, if I invested $10,000 and the bank said it will give me a 1% interest, that will be my rate R. The $10,000 will be my P. And the 1% annually. So every year I'll get 1% interest, which is the T. So to calculate the interest rate here, it will be 10,000 times 1% will be 0.01. So 10,000 times 0.01 times 1, because it's first year. And that will give us around $100. So that's how we calculate simple interest. Again, we are going to see an example. To calculate a simple interest, we multiply the principal amount times the interest rate annually times the time in years also. Also, we can calculate the compound interest. The compound interest will be the principal amount times 1 plus the annual interest rate, which is R, raised to the power T, that is the time in years. Now, what's the difference between simple interest and a compound interest? The difference is that in simple interest, if I invested $10,000 in the first year, my interest that I earned was $100, that amount will not be added. We are not going to add that amount to the principal. The amount will be given to you. So the following year, we still calculate the interest rate of only $10,000. But with the compound interest, the interest you earn every year will not be given to you. It will rather be added into your principal, which means you earn more money, because the first year I earned $100 interest. The $100 interest will be added to $10,000. So which means in second year, I will get interest on $10,100, not interest on $10,000. So that's the difference between simple interest and compound interest. Compound interest, the interest will be added every year into your principal amount, and you get new interest rate for the whole amount. With a simple interest, every year the interest will be given to you. The interest is not going to be added into the principal. So let's start with our first example here. Now the example says, suppose that the total cost of renting a car consists of a fixed cost of $35 per day. So a fixed cost means when you rent a car today, whether you drive it or not, you have to pay $35. Then we have a variable cost of 15 cents per mile. So the variable, that's why it's called a variable cost. The cost here varies. So the more miles I drive, the more money I'll pay. So 15 cents per mile will be a variable cost, which means if I drive it for only 1 mile, I'll pay only 15 cents. If I drive it for 2 miles, I'll pay 30 cents. But the fixed cost doesn't change. It's there. Now the question says we should write a cost function that represents the cost of driving X miles in 1 day. So this would be a simple equation in algebra. So here we can say that the cost function will be the fixed cost plus the variable cost. The fixed cost is $35 plus the variable cost is 15 times X because X miles. Then after that, we're going to find the cost of driving 500 miles. So after I get the cost function, I will substitute 500 with the X miles, and that will give me the cost of driving for 500 miles. So let's see the result or the solution. So here we can see the formula for calculating the cost is C at X, because X will be our unit for the miles, X miles, is variable cost plus fixed cost. So we know variable cost, based on the question, we say let X represent the number of miles driven in one day. So variable cost, remember, is 15 cents per mile. So it will be, in dollars, it will be 0.15, 15 cents. So variable cost will be 0.15x, but the fixed cost will be $35. Now, why do we change the 15 cents to dollars? Because both variable cost and the fixed cost must be in the same unit. Either both of them will be in dollars or both of them will be in cents. So if I write 15x here, then I have to write 3,500 cents. So here, our answer will be 0.15x plus 35. Now in B, they said how much it will cost to drive 500 miles. So in this case, I'm going to substitute x for 500, solve the equation. So here we say C at 500 will give us 0.15 times 500 plus 35. And that will give us 75 plus 35. And that will give us $110. So observe that if you do not drive the fixed cost, as we said earlier, if you didn't drive at all, the fixed cost, you still have to pay the $35. So our initial cost, the fixed cost, is always $35. So let's try example 2, which is also a business question. Here we said a manufacturer determines that the revenue generated by selling X units of a product is linear function of X. Now, if the revenue from 20 units is 380 and the revenue from 15 units is 285, we should find the revenue function. Now, in this case, the key point here is that the revenue generated by the selling X unit of a product is a linear function. So here we know it's a straight line function of X, which means X, the highest exponent is 1. And also if we have a linear function, the rate of change is constant, which is the slope, a constant. So that's the two conditions here. So in this case, first, since the revenue function is linear, as we said earlier, we are going to treat the given information as 2 points. The slope is constant. Now, if it's not a linear function, then we can't use, because if it's not a linear function, the rate of change will not be the same. Linear function rate of change, which is the slope, is always the same. So here we have 20 units is 380, and at 15 units, we have 285. Now the question says we should find the revenue function. So here, since it's linear function again, we are using a slope concept. So we use the formula for slope to generate the function. And here we know m equal to y1 minus y2 over s1 minus s2. So based on the question, you can see that the number of units will be the x-axis and the amount will be y. So we can have 380 minus 285 divided by 20 minus 15, or 285 minus 380 divided by 15 minus 20. So that's what we have here. where X is the number of units sold and Y is the revenue, as we said. So we have 380 minus 285, because if we need a function, straight line function, number one item we need is the slope, because the slope will give us the steepness of the line, the rate of change. So we find the slope, as we said, the first point and the second point. So we have 380 minus 285, or 20 minus 15. Or we can say 285 minus 380, but divided by 15 minus 20, we get the same answer. So based on this, our slope was 19. Okay, so if we get 19, then we are going to use the point slope form to come up the equation. So we can take any of the 2 points. I can use 380 and 20, or 285 and 15. You can use any of the 2 points. We plug them at the y1, s1, and we plug the slope also. Then we have the function. So here we decided to use the 380 and 20. So we plug 380 and s1 20. Then we solve the equation. So we get 19x minus 19 times 20 will be 380. And then we have minus 380. Minus 380 cross the equal sign becomes plus 380. So here we can see that minus 380 will cancel plus 380. So we get y equal to 19x. So this will be our, again, revenue function. So here we say the revenue function is r at x equal to 19x. Now let's try a third example. This is a break-even point. In business, a break-even point is when a company didn't make no profit, and also that company didn't lose anything. So no profit, no loss. And that's the break-even point, which we can say, okay, the total revenue generated equal to the total expenses. So here we have a question saying that the grain bed company determines that the cost of manufacturing maize beds is $2 each, plus $300 per day in fixed costs. So if I make only one bed, then it will be 2 plus 300. If I make two beds, it will be 2 times 2, so 4 plus 300. If I make 3 beds, 2 times 3, again, yeah, listen, because manufacture the main beds is $2 each. So the variable cost will be 2x. We have a fixed cost of 300, so we always add 300. Now here we say the company sells the bed for $3 each. What is the break even? So the break even, as we said earlier, it will be the total revenue equal to the total expenses. So here we are going to have 2x. Let's say x represents the number of beds made. So it will be 2x plus 300 equal to 3x. Let's see the equation. So again, we said the break-even point occurs where revenue and costs are equal. They are equal. So let S represent the number of beds manufactured in a day. So the revenue generated, remember, is $3 per bed, so it's 3x. And also the total cost, remember, we said 2 per bed, so 2x, plus the fixed cost 300. So break-even point means the revenue generated equal to the total expenses of the total cost. So 3x equal to 2x plus 300. And here we are looking for the value of x. So the value of x will tell us that the number of beds we need to develop or manufacture and sell 300 beds. If we sell 300 beds, the company is not going to lose, and also it's not going to make a profit. Now, when we sell below 300, the company will lose. If we sell above 300, the company will start to make profit. So that's the graph here. You can see the break-even point where both the costs and the revenue function met. And this happens when the selling is 3 price. So here we say, so 300 bets must be made and sold each day for the company to break even. Also, the company must sell more than 300 bets each day to make profit. And also, if you sell less than 300 each day, is going to lose some money. So let's move to another business application problem, which is modeling in production. So here we say, suppose that a company has determined that the cost of producing X items is given as 500 plus 140X. So 500 will be our fixed cost, 140 will be our variable cost. So that's the cost function. And that the price it should charge for one item is P equal to 200 minus X. So the price P is 200 minus X. Now the first question said we should find the cost function. The cost function, we already seen it here. They say the cost of producing 500 plus 140X. And also the revenue function. So the revenue function will be the price times the number of units sold. And find the profit function. We subtract the revenue and the cost. So the cost from revenue. Then find the break-even point. We equate costs equal to the total revenue. So let's start with the first one. Find the cost function. So the cost function is given as C at X equal to 500 plus 140X. It's already given because the question said that the cost of producing X item is 500 plus 140X. 500 is our fixed cost, 140 is our variable cost. So that's the first answer. Now B, the revenue function will be found by multiplying the price, as we said earlier, the price for one item by the number of items sold. So we know the price, R at X will be P times X. The price is P times X. So here we know P is given to be 200 minus X. We multiply by X. So that will give us 200X minus X squared. So that will be the revenue. Now we go to C. We should find the profit. So to find the profit, it will be the difference of the revenue and the cost. So we have R at X minus C at X. So we know R at X is 200X minus X squared. C at X is 500 plus 140X. So that's what we have here. We open the parentheses and we combine the like terms. Our final solution will be minus X squared plus 60X minus 500. So we can see here minus X squared, then minus 500 minus 140X. Minus 140X with plus 200X will give me positive 60X. So we have 60X. Then we have minus X squared by itself. And also we have minus 500 by itself. So the last section is how do we find the break-even point? So to find the break-even point in this question, we already know the revenue function, we know the cost function. So we equate it together. R at X equal to C at X. R at X is our revenue function. C at X is our cost function. So we have 200X minus X squared equal to 500 plus 140X. The goal is to find the value of X. X is the number of items that we need to sell in order to have a break-even point. So we equate, since this will be a quadratic equation, we equate everything to 0. So we get positive X squared minus 200X will go to the right side, plus 140X will give me minus 60X. Plus 500 is already in the right position, so we still keep by plus 500. So here we can factorize. We use minus 10 minus 50 because minus 10 times minus 50 will give me plus 500. Minus 10, minus 50 combined together will give me minus 60. So this means our X value will be 10 or 50. So here we have two break-even points. If we sell 10 items, we have a break-even point. If we sell 50 items, also we have a break-even point. So we can see the equation, two break-even points with the cost of revenue function. So this model showed that, as we said, profit occurs if the company produces between 10 and 50 items. We're going to discuss calculus techniques for maximize profit later. In calculus to maximize profit, normally we use the differentiation. We differentiate or find the derivative. We use the derivative techniques. Now here we say, suppose that the supply function for a particular product is given as follows, and also the demand function is given as follows. The supply function is S at X, which is S squared plus S plus 3. Then the demand function, which is D at X, is S minus 5 all squared. Now, equilibrium point means when the demand and the supply are equal. And we know that this is economics. In economics, we know that when the demand is high than the supply, the price will go up. When the supply is very high than the demand, we may have a surplus items, so the price will go down. So we always want to get to the main best point, which is the equilibrium point. Equilibrium point means when the supply and the demand are the same, they are equal. So again, price go up when the demand is higher than the supply. Price goes down when the supply is higher than the demand. Equilibrium point means when the demand and the supply are the same. So that's our question here. We have the cost function. We have the supply function, which is S at X, and also we have the demand function, which is D at X. And here we say where S represents 1,000 of units and P represents thousands of dollars. Now find the equilibrium point. As we said earlier, equilibrium point is when the supply is the same as the demand. So we are going to start finding in business, we find the break-even point where the company doesn't lose and also doesn't make no profit. In economics, the supply and demand is the same. That's the equilibrium point. So it's kind of using the same concept. We are going to have the supply equal to the demand, or S at X equal to D at X. So we substitute the formula. We have the supply formula, and also we have the demand formula. The supply formula was S squared plus S plus 3. We can go back to the equation. Supply is S squared plus S plus 3. Demand is X minus 5 whole squared. So we are going to write S squared plus S plus 3 equal to S minus 5 whole squared. Then we solve for the equation. So the S value will tell us the number of items that need to be supplied that will create the equilibrium, the price. So normally in this kind of problem, we will find the price, the equilibrium price, and also the equilibrium items we have to supply. So let's solve this problem. We open the parentheses here, so we get S squared minus 10S plus 25. That's S minus 5 squared. We give it S squared minus 10. So now we can combine the like terms and solve the equation. So here we get 11x equal to 22. And x will give us 2. So the equilibrium here will be 2. Now from here, we can also find the P. So we take one of the equations. In this case, we take the first equation, S squared plus S plus 3. When we plug the 2, we get 9. So this means at the equilibrium, we need to have a price of 9, let's say $9, and we supply 2 items. So 2 items. So this is the graph. When we graph the supply function and also the demand function, we can see the intersection of the point is called the equilibrium, which is 2 and 9. So S will be the unit in thousands, and P will be the price also in thousands. So if we sell 2,000 units at a price of $9 or 9,000, that would be again the equilibrium point. So here we say the equilibrium point occurs when S is 2,000 units and the price is 9,000 P. So let's see another question. This time we are moving to fixes. We saw an example for business, interest, cost, function, revenue, and also we saw break-even point. These are all business questions. And we saw one economics problem, finding the equilibrium point when the supply and demand function is given. Now our last example being fixes. So here we say the basic law of physics states that when an object is dropped in a near vacuum, the distance it falls varies directly with the square of the elapsed time. So if an object dropped in a near vacuum falls 64 feet in 2 seconds, now the question says, how far does it fall in 3 seconds? Assuming that the object does not hit the ground before 3 seconds have elapsed. Now they give us the theory here already. They say the basic law of physics says that when an object is dropped in a near vacuum, now the distance it falls varies directly with the square of the time. So the distance that it will fall will be varies directly with the square of the time. So that's the first thing we have to know. The basic law of physics described above can be modeled by this equation. We saw that the distance varies directly with the square of time. So we have D equal to KT squared. K will be the constant. T is the time. So distance varies with the time squared. So where D is the distance, T is the time, and again, K will be the constant of the proportionality. Now, if we know this B equal to KT squared, now we look for K. The condition says 64 is 2. So we substitute. We have this value. Now we are looking for 3 seconds. So if we find the value for K to be 16, we can now use the same formula. We plug 16 for K, 3 for T squared, and that will give us the distance for 3 seconds. So we get 16 times 3 squared, and that gives us 144 feet. So this means, again, if the item is falling for 3 seconds, takes 3 seconds, it will fall up to 144 feet. So 144 feet in 3 seconds. Then we have a stock market example. Here we say that Scott wants to buy a total of 500 shares in the stock market. He will buy X shares at $4 per share and the rest at $6 per share. So we want to buy 500 shares. But there are 2 types of shares. We have $4 and also the rest will be $6 per share. Now the question says, write a function for the total cost of the shares. And also what will be Scott's cost if he buys 200 shares at $4. So the condition given to us is that since Scott will buy X shares at $4 per share, he must buy 500 minus X shares at $6 per share. So the total cost function is 4x plus 6 times 500 minus x, based on the condition of the question. Since Scott will buy X shares at $4 first, then he must buy 500 minus X at 6. So that will be the total cost. So here we get 3,000 minus 2x when we solve the expression. We get 3,000 minus 6x. So minus 6x plus 4x will be minus 2x. But B now said, if Scott buys 200 shares at $4, then X equal to 200. And we have 3,000 minus 2 times 200. So the first thing we need to find is the equation, the cost function. And the condition was given here. Here we say Scott wants to buy a total of 500 shares in the stock market. But he will buy X shares at $4 first per share, and the rest at $6. So that's why the cost function again, we have the first part 4x, and then the rest $6. We are buying it, we are selling a total of 500. It's buying a total of 500. So if you buy first 4x, this number for $4, then the rest will be 500 minus S, the rest will be $6. So if you buy 200 for X, then $6 one will be 500 minus 200. So if we know this equation, now the second question says, if Scott buy 200 shares for $4, then S equal to 200, because he buy 200 shares. So S we substitute S for 200. So we get 3,000 minus 2 times 200. And that will give us $2,600. Another example for phone call charges. Now here we say, suppose that the cost of an overseas call is $9 for the first 3 minutes or less. So when I make a call, I'll pay $9. If the call is 3 minutes or less, which means if I start making the call, the first 1 second, I'll pay $9. Now the second option said all less and plus. So again, the first, we pay $9 for first 3 minutes or less. 1 second up to 3 minutes is $9. But if we make more time, it will be plus 95 cents for each additional minute. So write a function for the cost of calling S minutes, assuming that a fraction of a minute over 3 minutes is charged, the corresponding fraction of 95 cents. So now we can see everything. $9 is the first 3 minutes or less, then 95 cents for additional minutes. So we say, okay, let S represent the length of the call in minutes. So we're going to have two functions, which is called the piecewise function. We know we pay $9 if only X is less than or equal to 3. And of course, it have to be greater than 0 because it's time. Time is positive. Then the second option, when it's more than 3 minutes, remember the first 3 minutes, you paid $9. So the rest you pay 0.95. So I'm going to, it depends on how many minutes I make. If the S minutes I make is 4, then I'm going to pay 0.95 times 1, because I have to take the first 3 minutes out of the X, because that was the first 3 minutes they charged for the $9. So we have the $9 down from the first 3 minutes. That's why we have -3. So if we make 10 minutes, then the first 3 minutes is $9. The remaining 7 minutes will be 7 times 0.95, which will be 10 minus 3 is 7. But if the call is between 0 to at least 1 second to 3 minutes, then we get $9. So they said the function is defined in pieces because the format to be used depends on whether or not the call lasts longer than 3 minutes. First, the call will last not more than 3 minutes. Second, the call lasts over 3 minutes. So that will be our conclusion of these lectures. Again, these lectures focus on the business applications and also economics in using, again, mathematical modeling. So again, wish everybody the best. Thank you.